NCC is a performance-based code requiring all new buildings to meet minimum performance requirements. A deemed to satisfy approach is the optional pathway for demonstrating compliance used by this calculator, which applies to some Class 2 to Class 9 buildings, excluding Class 8. The lighting calculator is a non-mandatory guidance tool, helping you apply the deemed to satisfy provisions of Part J6 in NCC Volume 1. The calculator is a Microsoft Excel-based tool and can be downloaded from the ABCB website. This video demonstrates using the non-residential lighting, Class 2 common areas, Class 3, Class 5 to 7 and Class 9 buildings option within the calculator. It covers the basic functions of the calculator, including the necessary data input into the different cells. The calculator must be used in conjunction with the NCC. The calculator opens with the main menu. Here you can select which calculator you wish to use. The two options are the residential lighting calculator for Class 2 SOUs or a Class 4 part of a building, and the non-residential lighting calculator for Class 2 common areas, Class 3, Class 5 to 7 and Class 9 buildings, which is the focus of this video. You can also navigate to the guidance materials from the main menu or via the tabs at the bottom of the screen. Take note of the color guide on the screen, as this will help you when filling out the cells in the calculator. For this example, we'll be looking at a small Class 5 office building. So let's choose the non-residential lighting calculator. This calculator automates the selection of illumination power density and adjustment factors, and undertakes calculations for illumination power loads for the energy efficiency provisions of Part J6. Illumination power density is a defined term in the NCC. It means the total power in watts that will be consumed by the lights in a space, including any lamps, ballasts, current regulators and control devices, divided by the area of the space. It excludes lights plugged into general-purpose electrical outlets for intermittent use, such as floor standing, desk lamps or work lamps. The measurement of illumination power density is watts per metre squared. The intent of the deemed to satisfy lighting provisions is to enable lighting to be used in a responsible manner, thereby avoiding excess energy use and greenhouse gas emissions. In order to achieve effective results, the calculator relies on entering accurate information, consulting with lighting manufacturers for the lighting power information, and architects and draftspersons for any lights in a space. No nominal or general allowances are to be used in the calculator, only those for the actual lighting design. To find out the correct lighting power information, consult the lighting manufacturer. This information needs to be checked and verified against the design documentation for compliance assessment. We'll look at the calculator in three parts. Part 1, Building Information and Parameters. Part 2, Lighting Details Table. And Part 3, Calculated Outcomes. Start by entering the building name and description. Then select the building classification from the drop-down box. You can find more information on building classifications and the associated buildings in Part A6 of NCC Volume 1. Now input the number of rows you'll need for this assessment. This usually corresponds with the number of rooms or spaces being assessed. Once you've entered in the number of rows required, the ID cell will appear red. Click the small arrow icon in this cell and tick the box accompanying the number entered, and rest of the rows will appear. 40 is the maximum number of rows. Before moving on, check all the cells from Part 1 are filled out. If these cells are not filled out, the calculator will not work. Start by entering any identifier needed into the description cell. This can be the room name and lighting system, or it could be another identifier that relates to the building documentation, such as the room number. When you move to the next cell, you will notice the description, floor area of the space, design illumination power load, and space cells change color. This indicates that these cells are required to be filled in order for the calculator to work. The floor area of the space cell is used to enter the area of the space in meters squared. The floor area is measured within the finished surface of the enclosing walls. The next two columns, perimeter of the space and floor to ceiling height, can be used to increase the allowable wattage of the space. This adjustment factor is called the room aspect ratio and applies to small enclosed spaces. The calculator automatically calculates the ratio when data is entered in these cells. The perimeter of the space and the floor to ceiling height are both entered in meters. The design illumination power load cell is where the total sum of the power in watts is entered. This is calculated by multiplying the floor area of the space by the maximum illumination power density associated with the function and use of the space, selected from the drop-down box in the next cell. The maximum illumination power density of a space and its associated function and use can be found in Table J6.2a in Part J6, Artificial Lighting and Power of the NCC Volume 1. Adjustment factors can be selected from the next series of columns using the drop-down boxes when lighting control devices are used. Notice these cells have not changed colour, meaning they only need to be filled if they apply to the lighting design. By using an adjustment factor, the allowance in watts per metre squared will increase for that space. Click on the Adjustment Factors button to view the adjustment factors as well as any prerequisites for their use. Some adjustment factors require additional information. If needed, prompts will appear in the highlighted columns. The cells will display in a shaded gold colour and detail the missing input in red in the calculated outcomes. Using a second adjustment factor is also allowed. However, an advisory warning note will appear as the control devices selected have to be different, but compatible for use with each other. The last input available is any light color adjustment factors. Where two are selected, they must be different to each other. The spreadsheet automatically calculates two outcomes: the system illumination power load and the lighting system share of the aggregate used, illustrated as a percentage. If a result is displayed in a green cell, it indicates the result is a pass. If it displays in a red cell, it indicates a fail. The first column provides the outcome for the maximum system illumination power load for that space. You'll notice at the bottom of this column is a total which indicates the maximum system illumination power load for the overall design. This will also display green for pass and red for fail. If an individual space is indicating failure, but the overall design still passes, it means you have gone over the allowance for that space, but there is an excuse allowance from other spaces being used. Trading between spaces is allowed so long as the overall design complies by staying under the total allowance for all the spaces combined. The last outcomes column is the lighting system share of the percentage of aggregate used. The first percentage shows how much an individual space within the lighting design is using out of the total allowance of the overall design. The second percentage is the same for every cell in the column, displaying the amount of the total allowance that has been used by all the spaces combined. Below the last column, you'll see a large cell next to "If inputs are valid." This cell represents the overall outcome of the lighting design. If the cell is showing green with a tick, the design is compliant. If the cell shows red with a cross, the lighting design does not comply and needs to be reconsidered as appropriate. To the right of the calculated outcomes is additional information summarizing all of the inputs from the lighting details table. It provides calculated results of the room aspect ratios for each space and the values of other adjustment factors applied. Remember, the lighting calculator input data needs to be checked and verified against the design documentation for compliance assessment. A copy of the calculator can also be printed or saved as part of the design documentation. Further details about the lighting calculator, including additional examples, are provided in the Energy Efficiency Volume 1 Handbook and other resources from the ABCB website.